Starlink triples speeds with a data center in space. Let's go check it out. Hey everybody, welcome back to the channel. Thank you so much once again joining me for tea time. Look at that. What do you think about this mug? Once again, it is Jack. You think I like Jack? I do. I hope you're joining me with your cup of tea, maybe a cup of coffee, hanging out, talking tech, talking photo, talking video. Today is a technology day. We're gonna get a little bit deep into it today. If you like the tech and the geekiness of it all, you might want to stay for this one. I had a lot of fun researching this. I think that this is, I've been talking about this for the last couple of years, but anyways, before I get into it, I want to say, well, I guess happy Halloween. We're only a couple of weeks away. My favorite time of year. I have my shirt on. We got the mug. We got all of this going on. Hope you guys are having fun with Samhain, Halloween. I know I do. Anyways, before I get into all of this, I just want to say, if you get anything out of this, please consider giving it a thumbs up. That's very, very helpful for the algorithm, for the YouTube gods to shine their light on the channel nicely. Also, if you're not subscribed, consider doing so. If you are subscribed, thank you. Click this little button over here so when I go live, when a new video comes out, you'll be notified of it immediately. And today, I think we're going to be going live. Friday the 13th, tonight. I think it'll be kind of cool. Usually about 8:30. Eastern Standard Time is when we go live, so check that out. Also, if you want to say thank you for all of my hard work, there's a little thank you button down here. You can click on that if you want. Give $1 or $2. If not, that's fine. Consider becoming a member of the channel. That'd be even better. And if you want more Starlink content, I put together a Starlink playlist just for you. Click on this over there. And finally, if you're looking for a VPN or you need a static IP address or do port forwarding, check out PureVPN. They gave us a promo code, which is JCristina. Use that at checkout. You'll get 15% off, or you can just simply use the URL jcristina.com/VPN. So guys, now that that's all out of the way, I know people complain about it, but I have to do it because if I don't promote myself, who the hell will? People get so upset about it, you know, so upset, but it kind of is what it is, right? We do what we have to do. So anyways, let me start out by saying I've been talking about this, like I said before, for probably about 2 years, ever since beta, okay? I said, wouldn't it be cool to have a NOC, a network operations center, or a CO, a central office, or a data center in LEO? In low Earth orbit. Wouldn't that be awesome? This way you wouldn't have to, let's say, move data from LEO back to the Earth and back to LEO and back to the Earth and back and forth, and it will really reduce time. It will really reduce latency. It will just speed things up. It would be a better system. And I said that this is something that could be possible. And I've been kind of just mulling through it for the last year, year and a half. And I was thinking to myself, you know, maybe this is not the answer. Maybe there is something better. And that's what I want to get into today. Maybe it's not the data center. Maybe it is something else. But let's get into it a little bit. And once again, bear with me. It's going to be a little bit longer of a video, but I'm going to try to give you a lot of information so you understand like how all this stuff works and how it could work and really make our speeds faster. I alluded in the description or the title of this video that this could possibly produce 3x the speed. Well, the latency alone could actually be more like 5x difference if this was to come to pass, what I'm going to tell you before the end of this video. So we'll see. And most importantly, I want to know your thoughts about this. So down below, you're probably smarter than I am. I'm not an engineer. Let me know where I got things right and where I got things wrong. The premise behind this is simply providing data without having to bounce the information back and forth. Like I said before, from the terminal up into LEO and then back down and back up and in and out and all the rest of the stuff, it just is a time-consuming thing. The speed at which the data goes from your terminal to the satellite and back down is really not that bad. It's only about 4 to 6 milliseconds, but where things slow down is on the ground. Once it gets to the ground station, from the ground station to the POP and all of this, then we end up with a lot of latency that goes on. So the idea that I've always had was having one of these data centers up in LEO so that the request would go up, the data center would have the information and would send it back down to you, and it really wouldn't have to traverse the intrawebs at all because the data is already there. So I think that the idea was feasible. Okay, but I do think that even though SpaceX Starlink does have these extremely fast, high-speed data communication lasers that are on board all of these satellites, which will definitely help, having a CO or a central office or a data center in LEO can really pose an issue due to the size that it has to be. So there's a few things, a few points that I kind of been writing down over the last couple of months on what could be the problems. Because yes, the solutions sound fantastic, but you always have to look at both sides of everything. What are the inherent problems of having something that is a data center in LEO? Well, number one, it would be the size and weight. Weight and size is everything when it comes to payloads and being able to launch stuff into orbit. That is a major consideration because even if you make something really compact, when it is a server, right? When it is a data center, there's a lot of servers, a lot of gear, and it becomes heavy really quickly. Trust me, all of the hard drives that I have over there piled up in my Unraid server is probably about 50 pounds the time you weigh the entire massive contraption. I mean, it's heavy, all right? So they weigh a lot. It's a lot of mass to it. The other problem that I was considering was power consumption. I know how much that my server, my Unraid server, uses, and it's a good amount of power. So even though there is a possibility to make it low powered, these servers, the problem is they are relying on batteries and solar panels, and that is it. There is no way to get any additional electricity, no more energy to these satellites unless they had onboard nuclear type of energy producing systems. And there's not very many of those out there. And usually those type of satellites are going off into space outside of our solar system, and they're using nuclear to be able to power them. So I don't think that that's going to be a possibility. Also, I was thinking about radiation and radiation hardening, because remember, all of these servers, all of these systems, anything having to do with data, when they get hit with or bombarded with certain types of radiation, it can cause data loss. There is a lot of problems that go on with radiation, and they would have to really be encapsulated well. Also, thermal management. I mean, at one point, the satellite could be freezing cold, another point, it could be really hot. You can't have a hot server, it's not going to work. You can't have a frozen server either. So thermal management is an issue also, to make sure that the data is actually functioning, or these computers are functioning well. Also, I was thinking about redundancy. If you had a data center, you really can't have one, because one is none, as we always know. Two is one, three is optimal. So you'd have to have multiple data centers for redundancy. So if one went down, the other one can pick up the load, so to speak. So you'd have to have multiples of these. So now, once again, we're getting into the woods, getting into the thick of things a little bit. Now, when it comes to data transfer, is data transfer a problem? Nah, not really, because with data transfer, we now have those high-speed lasers, communication lasers, where they're all linked together, or the majority of these satellites, over 50% of them, are linked together. So transferring is not going to be an issue. Another thing that I was thinking about was security. If you actually had a lot of data, some of this data might be sensitive, sitting on a satellite, right? Or now let's call it a data center satellite, a big mega satellite. Could there be an issue with data security? Remember now, the data would be sitting there for a specific period of time instead of it being transient, coming and going. Now, we can get into TTL, or time to live. I'm not going to get into that. Basically, that's the amount of time that a certain portion or certain piece of data is left on board, let's call it, before it is flushed out. TTL, or time to live. Once again, we don't want to get too deep in the woods here. So that was another idea that I was thinking about. So all in all, when I look at the idea of having a data center in space, is it feasible? Is it practical? Is it possible? Well, yeah, it's possible, but feasible and practical, maybe not. All right. Could they do it? They could. And it's really going to depend on where Elon wants to go with this whole thing. So I was thinking about this a little bit differently. How about if we change this up a little bit? And instead of having just one massive data center, how about if we have some type of distributive network, a caching network? Now, caching is something that is very, very important, even to terrestrial type of bodies like ISPs and CDNs, which are your content delivery networks. These content delivery networks and ISPs have been doing some type of caching for decades, okay? It's a means of them faking speed. What they'll do is they will cache or keep the data in their data center. So when a user asks for or requests for the data, instead of that ISP having to go onto the interwebs, go into the internet and get the data over and over and over and over, it takes that information and it sticks it into its cache or into its servers. And then when the request goes out, it could just give it to the customer. And that is it. It is fast. It makes let's say, the perceived speed of the ISP much, much faster. And of course, it helps the data transmission rate of the ISP, of course, because now you have lower latency because it doesn't have to go onto the web. The data is already sitting there. Now we have to think about how much data and for how long, once again, going back to TTL and all the rest of the stuff. But this has been going on for a long time. And there's like a multitude of techniques of doing this caching. And I think that it could be very powerful even for SpaceX. Now you have like content caching, the standard content caching, where the CDN or the ISP will take frequently requested data and store it, right? So that could be images, videos, pictures, software updates. Maybe it's the Super Bowl and everyone keeps asking the exact same question. What is the score? What is the score? So the ISP would basically take that information and store it and update it continuously. Once again, this is a means of reducing latency, reducing load times, and basically giving the user the information that they want as quick as possible without the ISP or the CDN having to do much work because the data is already sitting there. There's another method called edge caching, and that is very interesting because edge caching basically puts the data on the edge, hence the name, of the customer. So let's look at this in terms of SpaceX Starlink. Edge caching would be like the equivalent to SpaceX taking the data in your node, something that you're looking for all the time, and keeping it or caching it at your local ground station. Makes sense, right? So that is the edge. That is as close to the customer as the ISP or the CDN can get that information, or Starlink can get that information to the user. So when the user puts in a request, it goes from their terminal up to the satellite, from the satellite down to the ground station. The ground station has the information already. That means it can send it back to the satellite and back to the user very quickly. You also have web acceleration, where the ISP or the CDN takes data and miniaturizes it. So what it does is it compresses everything. It compresses audio, it compresses video, it compresses photos. You see that all the time when you upload an image full resolution into Facebook and then you were to download it, you look at it like, what the hell happened here? Because they smashed the out of it, all right? They reduced it, they miniaturized it. That's more of that web acceleration type of technique. You also have transparent caching, you have dynamic caching, which is on the fly. You also have content preloading. Content preloading is very interesting because the way that works is that it anticipates what you're going to search for, what you're going to do on the web. This is kind of scary, but they've been doing this also for decades. Basically, it takes knowledge of what you are doing every day on the web and then preloading the information that it thinks that you're going to need. So if you go to, for example, Disney.com every single day, well, it knows that. All right. There's a cookie for that. It knows what you're doing every single day at 9 a.m. It will preload the Disney website, so that when you go to Disney.com, it pops up like that. And it didn't actually have to traverse the internet to go get that data because it's already there. Once again, that is that preloading type of means. So there's a lot of different ways of doing this content caching from the ISP or from the CDN. So I think that this would probably be an interesting way to go for SpaceX Starlink, because the way I look at this is this could turn into a distributive type of mesh network in comparison to a single source, or like I said before, maybe 3 data centers. Now, what they can do is they can do caching on, let's say, 1,000 satellites. And each satellite has a small portion of data that it stores. But all of these satellites have data. And I guess we can look at it this way. Let's say there was 1,000 satellites and they all have data on them. All right, all different data. And then you had one satellite that's all it does, or maybe 3 satellites, that's all it does is it does databasing. That's all it does. All day long, it parses through the data and it creates a database, kind of like a Google, right? That's all that it does. So the way that it would work is if you did a request, it would send a request up to the satellite. The satellite would say, hey, let's go ahead and check with the database to see if we have the information. If we don't have the information, fine, we'll send it back down to the ground station. The ground station could then go and get to the POP and to the internet and get the information. But if we do have the information in our database, go to the specific satellite that has it, get the information and send it back to us. And that's what it would do. And then once it has that data, it would send it straight back down to your terminal. So just think about this. Instead of the normal means of the way this whole thing works, if I put in a request today, right now for Google, and I do a search, it goes to my terminal and it sends that request up to the satellite. The satellite sends the request to the ground station close to me. The ground station sends it to the POP, or the point of presence. The point of presence, which is now on the internet backbone, sends it out to the internet, gets the information, retrieves it back. Then the POP sends it back to the ground station. The ground station sends it up to the satellite, then from the satellite back down to me. Holy shit. That's basically how it works. Well, in this scenario, if there was this distributive mesh type of caching system, what would happen now is my request, that Google request, would go from my terminal, it would go up to the satellite. The satellite would find that information, let's say, in the database, gather that information from another satellite, and then send it back down to my terminal, period. It never has to go to the ground station. The request never has to go from the ground station to the POP, then from the POP to the internet, and then all the way back, traversing all over the damn place. This would be mega. Just think about that. Remember, the interaction between our terminal and the satellite up and down bidirectionally is like 3 to 6 milliseconds. That's it. If the data is sitting up there in LEO on one of the cached satellites in this meshed distributive network, the data would come back down in less than 10 milliseconds. Because of course you would need a few milliseconds for there to be parsing of the database and then get the data from whichever satellite has it and then send it to you through the closest satellite that is now overhead. So this, once again, could really be, I mean, massive. This could be massive. And what I do like about this too is instead of having 3 of these massive COs, central offices or data centers in LEO, you are basically distributing this across, let's say, 1,000 satellites, 5,000 satellites, 40,000 satellites. And at that point, you do not have to worry about one satellite going down or 100 satellites going down. Because just like a mesh network terrestrially here on Earth, using a mesh network for data transmission, it would work the same way. When one satellite was out of the picture because it was down or there was some type of problem with it, that's fine. It just no longer is being used. And once it comes back online, it gets back into the mesh network, and then the mesh network starts using it again. It is mass redundancy, all right? I think the biggest thing here is going to be the fact that there could be sensitive data in LEO. How do we deal with that? Because once again, it will no longer be transient data, it would be actually data housed in LEO. Anyways, guys, what do you think about all this? Is this a possibility? I know I've talked about this for 2 years now, and this is a little bit different of a concept that I'm coming up with than the way I thought of things back then, but things have changed. We are now seeing SpaceX Starlink with extremely high-speed interlaser connectivity, where they are building a mesh network where they're always connected. All of these satellites are connected. I've always said that there is eventually going to be a time when we do not need ground stations. And this simple, let's say, means of transacting data from Earth to satellite could happen right next to a POP, a backbone, a point of presence, and take the ground stations out of the mix completely, because these satellites will be able to bounce the data so quickly through the speed of light, through these lasers, they can literally get it to a POP's location on the map in milliseconds, right? And then focus it straight back down for the actual transmission and not have all of these ground stations all over the place. Of course, I'm not an engineer here. I am sheerly speculating here. I want to know your thoughts. Once again, a lot of you guys are much smarter than I am. Down below, let's learn together. In the comment area underneath this video, let's have this discussion. What do you foresee? Is this something that is possible? Do you think that if they did create this mesh network, this caching mesh network that I'm proposing, will this truly increase speeds 3x? I do believe it could, because if we can get transitional times down to sub 10 milliseconds, well, that's going to be much quicker than 3 times. That's going to be probably more like 5 times quicker than what we're seeing for latency currently. So once again, I want to know your thoughts down below. Let's have this discussion. I hope you enjoyed this. If you have, throw it a thumbs up. That would be awesome. And finally, head over to my website, JCristina.com, where you can find all the photography tools I've invented for you and me over the years. And hopefully there's something there that you might like. And if there is, please pick it up and support me and my family. That's it, guys. I'm out of here for the end of the vlog. Many blessings to you and your family. Stay safe, stay healthy, and we'll see you in the next one. Love you all.